So today we're going to look at the topic of solving some simple equations with one variable. So using some shortcuts to explain and show our steps. So we're going to have a look at this question first of all. Okay, so if we have this instruction to simplify this expression, so we have 4x subtract 2 plus 5x plus 1. So algebra is a language kind of in itself that we use in math to represent various things. We use letters of the alphabet, so generally X and Y, but we can use any letters of the alphabet, A, B, C. So we're going to look at this first question, simplify this expression. So an expression in math is quite specific in that we just have terms like this. So this is just an example of an expression, and you'll see the difference compared to an equation in a moment. So when we're working with algebra, again, I'm just going to kind of work down the page, is we're looking, when we're adding and subtracting algebraic terms, okay, so 4x is one term, we're subtracting 2, or you could look at that we're adding -2, and we're adding 5x, and we're adding 1. Each of those are terms, and when we're adding and subtracting, we need to look for what we call like terms. So again, this is very specific in math, that we want to look for terms that have the same variable with the same exponent. Okay, and here we can see we've got 4x. We recognize that the exponent must be 1 because nothing is written there. So if we wanted to say that that was 4x squared, then we would have to specifically write in the squared 2 here. So we recognize each of these has an exponent of 1, and we don't normally write that. So I'm just going to erase those now. But we recognize that it is an exponent of +1. So when we're simplifying this expression, we're just going to add together the like terms. Okay, this special term that we use here with algebra. So, easiest way is I'm going to identify 4x plus 5x, so take in the sign there. Those two are like terms. Same variable, both x, exponents the same, 1. Now the number in front of the variable is 4 here and 5 here, so they're both positive. There's nothing written here, so we recognize this must be positive. The number in front of the variable is the coefficient, what we call the coefficient. So 4x plus 5x, that means we have 9x of that. We can just add those together. Now, the other two like terms are the constants here, they're just the numbers. We've got -2 plus 1. So if we add those together, that means we get 9x subtract 1. So then that is our answer. We've simplified this expression as much as possible. 9x subtract 1. There's no more like terms that we can simplify. So the important thing here is like terms. We have the same variable and the same exponent. So the second one, we're going to simplify another expression, 5x plus 1, subtract, and now we've got brackets or parentheses, 2x plus 3. So what we need to do here is we need to first of all expand the bracket so we can get all of the individual terms, and then we can look for like terms to add together. So the first thing that we need to recognize here is that this negative sign here means that we need to multiply everything in the bracket by -1. So it just means everything in the bracket, the sign is going to change. So keep the same flow of the question here. We've got 5x plus 1. Now with this negative sign, we've got to multiply everything in the bracket by -1. So -1 times 2x is going to give us -2x. The -1 times +3 is going to give us -3. So now once we've got all the individual terms, we can identify the like terms. So the same variable with the same exponent here, with catching the negative there. So we've got 5x subtract 2x is going to give us 3x. And then when we look at the two numbers, constants, 1 subtract 3 is going to give us -2. So now we've simplified that expression to 3x minus 2. We can't do anything more there. Okay, so let's have a look at the next question. So again, we still have an expression here. We're going to simplify this. -xy plus 2x squared plus 10xy minus y minus x squared plus 3y. Okay, again, it's important that we work down the page here as we work through this. So again, because we're adding and subtracting these terms, we have to identify like terms. So I'm just going to do that first of all. So I've got -xy here and I've got plus xy here. So those are two like terms. If I look at the x squared now, I have a positive 2x squared and I have a negative x squared here. And then the third that I have here, third type, is I've got minus y and then we've got plus 3y. So now if we add those individually as like terms, now the first term, -xy, doesn't have a coefficient there. So again, this is something that we recognize that must be a 1 here. So it's negative, so it means it's -1 xy. So now when we're adding the like terms, -1 xy plus 10 xy is going to give us 9 xy. And the other two like terms here, 2x squared minus x squared is going to give us plus x squared. And then when we look at the terms in y, we recognize that that must be -1y. There's no coefficient there, so we put that in the 1, -1y plus 3y. So that's going to give us plus 2y here. So now we've simplified this expression to 9xy plus x squared plus 2y. Again, we cannot simplify any more because we don't have any like terms with the same variable and the same exponent that we can then add together. Okay, if we have a look at this equation, solve 5 is equal to w subtract 2. Okay, we can see that w must be 7. 7 subtract 2 gives us 5. Okay, but using the rules of algebra, we want to isolate w. Okay, so we're just going to leave it on the right-hand side that it is here. And we can see that we're subtracting 2 from that. So if we actually do the reverse of subtracting 2, we add 2. We've got 5 on this side, but we need to balance it, so we've got to add 2. Then that means these two cancel. Subtract 2 plus 2 is going to give me 0. W plus 0 is just going to give me w on the right-hand side, and that equals 7. Now, in algebra, we always want to swap that around because whatever we want to find, the value of w, we want that on the left-hand side, and then we want the numerical value on the right-hand side, 7 here. So we're just going to swap those two around. Okay, now the shortcut to that is, again, if we just have our question here, we want to isolate w, so we know that we've got a subtract 2 on this side. If we take it over to the other side, the opposite of subtracting 2 is adding 2, and that will give us the 7 here. And again, we're just going to swap that around to give us w equal to 7 here. So, you know, I encourage you to use the shortcut if you can see that sort of more efficiently there. Okay, so let's have a look at number 6. We want to find the value of the variable. Okay, so in this case, we've got 5q is equal to 10. Okay, the variable is q, so always identify what the variable is. And we're multiplying here on the left-hand side. 5, we recognize this means 5 multiplied by q. So the rule is now, so that we can find the value of q, is the opposite of multiplying by 5 is dividing by 5. So we're going to divide each side by 5. Okay, and we're going to do that in this way. So we kind of got fractions now on both sides. Now, if we just look at the numbers, 5 divided by itself, 5 divided by 5 is just going to give me 1q. And 10 divided by 5 is going to give me 2. Now, we don't want to write the coefficient here, 1, so we're just going to leave it as q is equal to 2. Okay, we recognize it means 1q is equal to 2. We're just going to write it now here. So that means we've now found the value here, q is 2. And we can again plug it back in and check that it works. 5 times the value of q, 5 times 2, yes, it balances to 10. Okay, so always kind of do that check, and especially when you're doing more complicated questions, always plug in your answer to check that. Okay, the last kind of rule here is where we're dividing. So again, I'm just using different types of wording that they will use in questions. So find the unknown. Okay, in this equation, t over 7, t divided by 7 is equal to 3. Again, the principle here is that we have our value t divided by 7. Okay, the opposite of dividing by 7 is multiplying by 7. So if I multiply both sides by 7, okay, remember I have to do it on the other side to balance, and then we can simplify. So this is like 7 over 1, so it's like multiplying our fractions. So again, we can look diagonally to simplify. So the 7 and the 7 both are divisible by 7, so we know we're just going to get 1s here. 1 times t is going to give us t over 1 times 1 gives us the 1. 3 times 7 is going to give us 21 here. Now, because t over 1, we don't need to have over 1. Anything over 1 is just the item itself, so the variable here, t, is 21 here. Okay, so our value that we have, t is 21. And again, plug it back in to check. 21 over 7, yes, it balances to 3, so we've got the correct value. Okay, now the shortcut to this, okay, we had t over 7 is equal to 3, is we recognize we want to find the value of t. We want to isolate that on the left-hand side. With t is being divided by 7, so the opposite of that is multiplying by 7. So if we take that over the other side, instead of dividing by 7, we're going to multiply by 7. So it gives us our value of t here. Okay, so the shortcut is on the left-hand side, we're dividing by 7, so we're going to take it over to multiply by 7 there. Okay, so let's kind of use that now, all of these kind of shortcuts, to answer some more sort of interesting questions. Okay, so we want to solve 4x subtract 3 is equal to 2 subtract x. Now, x is appearing on both sides, that variable, and that's the value that we want to find by this question. Solving this equation means we want to find what that unique value of x is. So we're going to use all our algebra rules. Okay, the easiest way to explain this type of question, okay, and remember the equal sign is the balancing part, okay, is that we want to regroup. Okay, so again, this is something that we use in math specifically. So what I want to do here is I want to put all my variables on one side, on the left-hand side, and I'm going to put all my numbers, constants, on the right-hand side here. So already I have 4x here. On the right-hand side, I've got subtract x. So if I take it over to the other side, we're going to add x. The opposite of subtracting, we're going to add x. Now on the right-hand side, we've got 2. We're going to bring over the like term, the negative 3, bring it over to the other side and reverse its sign. So it's going to be add 3. Okay, and then we can add those two together, we get 5, and we can add these like terms. 4x plus 1x is 5x. Okay, but now we've got to do one more step so that we isolate x. So we recognize on the left-hand side that we've got 5 multiplied by x equals 5. So if we take it over to the other side, the opposite of multiplying is dividing. So 5 divided by 5, we have just our x on this side. And then we know a number divided by itself gives us 1. So now we can see that x is equal to 1. Okay, again, plug this back in to the equation. 4 times the value of x times 1. So we can normally write it using brackets and parentheses here. Subtract 3 is equal to 2. Subtract, and our value of x is 1. And we want to see if this balances. So 4 times 1 is 4, subtract 3. 2 subtract 1 is going to give us 1. So that's going to give us 4 subtract 3 is 1. So yes, it balances. So again, whenever you're solving equations here, you can always plug in your answer back into the original equation and make sure it balances to know that you've got the correct value there. If it doesn't balance, then there's a mistake somewhere, so you've got to kind of go back and check your steps. Okay, so let's have a look at this next question. So we want to solve this equation. So we have 3, open brackets, b plus 2, and subtract 2, brackets 1 minus b is equal to 5. Okay, so again, whenever we have brackets or parentheses, we always want to expand those and get the individual terms, so then we can add like terms according to the algebra rules. Okay, I'm just going to rewrite this back over here because I need a little bit more space. Okay, so if we expand the brackets, what we recognize is 3 multiplied by this bracket. So we know we're going to multiply everything in the bracket by 3. And so that's our 3 here. But here, another way that we can look at this is that we're going to multiply everything in the bracket by negative 2. So negative 2 times everything in the bracket. So 3 times b is going to give me 3b. 3 multiplied by positive 2 is going to give me 6. And now the second part of this, everything in the bracket needs to be multiplied by negative 2. So negative 2 times positive 1 is going to give me negative 2. Negative 2 times negative b is going to give me, so 2 negatives now give me a positive 2b. And that balances to 5. Okay, so now we can regroup and put all the like terms on one side and the other terms on the other. So my like terms, I've already got 3b plus 2b. So I'm going to add those two together as like terms. They're both on the same side, so we can just add them together. 3b plus 2b is going to give me 5b. And then the other term, this is a constant, I'm going to take it over as well as this on the right hand side. So we've already got 5 on this side. Bring over the plus 6 on the left hand side, so it becomes subtract 6 on this side. Negative 2 on the left hand side. When we bring it over, we're going to reverse the sign, so we add 2. If we then add these as like terms, 5 subtract 6 plus 2, so that's going to give us 1. So now we have 5b is equal to 1. Now we want to isolate b, find the value of b. 5 times the value of b equals 1. So we recognize we're multiplying on the left-hand side, so take that over to do the opposite of multiplying, to divide. So on the left-hand side, we're just going to have our b, 1b, but we're just going to write it as b. We're multiplying by 5 on this side, so when we take it over the other side, we're going to divide. So the 1 and take over the 5 to divide. And now we have our value of b, which is 1/5. Okay, again, we don't want to write that as a decimal unless we were told to do so. We'll just leave it as a fraction. Now, ideally, we want to substitute it back into the question to make sure it balances. That's going to introduce some fractions. So that's going to require some work. So I'm going to kind of leave that for you to confirm. Okay, but we've got our value here, which happens to be correct. B is 1/5 in this case. Okay, so we're going to have a look at this question where we're going to solve x over 2 plus 6 is equal to 1. Okay, so something here, now there are actually two different ways that you could look at this. So I'm going to kind of show you a little trick. So whenever we have like a fraction, and then we've got whole numbers here, but remember we've got an equation because we've got a left-hand side is equal to a right-hand side. So there's something clever that we can do here in math, another kind of shortcut if you like. So if I put these as fractions, I'm just going to put them over 1. Now, if I see the denominator here, we've got 1 of 2 here. If I multiply through the equation with that denominator, it means we get rid of fractions and then we can continue. So the fact that this is a 2 here, I can multiply every term through the equation and then we get rid of fractions. So basically I'm identifying this denominator of 2. I'm going to multiply by the first term. I'm going to multiply it by the second term, and I'm going to multiply it on the right hand side. Okay, and the reason we can do that is because we're keeping the balance. As long as we multiply everything individually on the left hand side with that value 2 and the same on the right hand side, then we've kept the balance there. So if we look at this individually, okay, again we can put these over 1. We can look diagonally. We've got our 2's, so each of these are divisible by 2, so we've got our 1 here. 1 times x is 1x over 1, so we're just going to simplify to x here. Now we're adding. We can't simplify diagonally, so we can just multiply through the fractions. 2 times 6 is 12, over 1 times 1 is 1, so 12 over 1 is just going to give us a number of 12 here. And likewise, on the right-hand side, we can't do anything diagonally, so we can just multiply across. 2 times 1 is 2 over 1, so we get 2 here. We want to isolate x. We're adding 12 on this side, so if we take it over to the other side, we can do the opposite of that of subtracting. 2 subtract 12, we just get x remaining on this side, and then we can write this value then as negative 10. 2 subtract 12 will give us a value of negative 10. Okay, and again, you can plug this back in, and this is a little bit easier for us to do. We've got x over 2 plus 6 is equal to 1 from our original question. If we plug that back in, x is negative 10 over 2 plus 6 is equal to 1. We simplify this. Negative 10 over 2 is going to give us negative 5 plus 6, and it balances to 1. Yes, that balances. Negative 5 plus 6 is going to give us positive 1, and it balances to the right-hand side of 1 there. So always kind of do that check. You might not get extra marks for that, but you can check that you've got the correct solution there, and it works. So that's one way of doing that particular question, okay? An easier way might be, okay, so I'm going to just look at the same question that we had, is, we've got the plus 6 on the left-hand side. So we can recognize if we take it over to the other side, so it joins its like term on the right-hand side, adding 6 on the left-hand side, so taking it over, we subtract 6, and then on this side, we've still got our x over 2. 1 subtract 6 is going to give us negative 5. So now what we have is x over 2 on the left-hand side is equal to negative 5. Now, using one of our shortcuts, x divided by 2, so we know if we take that over the other side, dividing by 2, we can multiply on the other side by the 2, and then we can just find our value of x. That will equate to x is equal to negative 10, which is what we had here. So this is just an alternative method because you're sort of identifying the like terms that you can add together on that side once you've move them over as you see here. So that type of question, again, if I look at that, it's not so easy to see what the answer is until we start using the rules of algebra and, working through that as you see here. So we're going to have a look at the last question here, question 11, and it's going to kind of follow on from the previous idea. So this is quite a complex question. So we're going to solve 6 over y plus 2 over 3 is equal to 5 over 2. Now, if you look at this, obviously we've got now fractions and we've got the variable that we want to solve to find the unique value of y is in the denominator. So it's quite a lot happening here with the fractions and the variable being in the denominator. So we're going to use the trick that we did before, but it's a little bit more complex here. Okay, so the reason being that we've got in this denominator y, in this denominator we've got 3, and in this denominator we've got 2. So what we're going to do is we're going to multiply through by 6y. Okay, so that we are then going to eliminate all the fractions and then we can add like terms according to algebra. So it does get a little bit complex here, and I'm just going to kind of write out the stages, and maybe you can do them a little bit quicker yourself. So we're going to multiply through by 6y, okay, because we've got a denominator of 3 and 2 by multiplying through by 6, and we've got a denominator of y. Okay, so the first term we've got 6y multiplied by 6 over y. Then we're adding, and then we're going to multiply the 6y by the 2/3. And then we've got our equals, and then we're going to use our 6y and multiply it by the 5 over 2. So I'm just going to put these in brackets so that we can do these correctly here. I'm just going to put this over 1 so that we've got these as fractions, and try and keep the equal sign in a straight line here. So if we look at the first bracket, the first parenthesis, what we notice is, because we've got multiplication of fractions, if we look diagonally now, we can simplify before we multiply across. So what we have in effect here is 6y over y. So diagonally, we've got y divided by itself. So that just means we have y divided by y is just going to give us 1, but we've still got the 6 in the numerator there. So now if we simplify this in the brackets, we've got 6 multiplied by 6, that's going to give us 36 over 1 times 1. We're just going to write it as the whole number there, 36. So by multiplying through by 6y, the first term, we've got rid of fractions, and we've just got 36 there. Now we've got the addition and the second bracket. So again, looking diagonally before we multiply the fractions, we've got 6y and we've got 3. So we can see diagonally there that we can divide each of those by 3. So 6 divided by 3 is going to give us 2. 3 divided by 3 is going to give us 1. So now if we multiply across with the fractions, 2y multiplied by 2, so that's going to give us 4y over 1 times 1 is 1. So we're just going to write that as a whole number, 4y. Likewise, if we look at the right-hand side, so again, just looking at the diagonals, we've got 6y and 2. We can see that both of those are divisible by 2. So 6 divided by 2 is going to give me 3. 2 divided by 2 is going to give me 1. So now if we simplify this, multiplying across, so we now have 3y multiplied by 5. So that's going to give us 15y over 1 times 1. So we're not going to write that over 1. So now what we've done is we've got rid of all the fractions, and then it's easier for us to continue. We can add like terms. So what we're going to look at doing here, just one way of doing this now, is we're adding 4y on this side. If we take it over the other side using the rules of algebra and the shortcut, we already have 15y on this side, bringing over the plus 4y on the left-hand side to the right-hand side, we reverse the sign, so we've got negative 4y, and we still have 36 on this side. So now we can add and simplify the like terms. They're all on the appropriate sides. So 15y subtract 4y is going to give us 11y, and then we've still got 36 on this side. Okay, and then finally we can work out what the value of y is, because we recognise on the right hand side it means 11 times the value of y. We're multiplying by 11. So if we take that over, we're going to do the reverse of that, dividing by 11. So we've got our 36, divide it by 11, and then we just have our y on the right hand side. Now, we always just want to reverse that around, because whatever we're trying to isolate or solve for the value of y, we want that on the left hand side equal, and then on the right hand side, the numerical value. Now, this is an improper fraction, okay? So just a reminder that an improper fraction means the numerator, the top number, is bigger than the denominator, the bottom number here. So 36 is bigger than the 11. So we could just leave our answer as in that way as an improper fraction, 36 over 11. Or if the question asked us to change it into a mixed number, then we could do that also. Okay, my preference would be to leave it as an improper fraction, but we could change it to a mixed number. So remember how we do that, okay? A fraction means that we can do division, 36 divided by 11. So how many 11s go into 36? And that goes 3, 11, 22, 33. But we have 36, so 3 times 11 gives us 33. We have 36, so we can subtract. So we know our denominator is the same with the 11. 36 subtract 11 times 3, which is 33. We have 3 remaining. So that would give us our answer if we wanted to write it as a mixed number, 3 and 3 over 11. Okay, so that question is very tricky. And, you know, again, if you're looking at the question, you would really have no idea what the answer is until you kind of go through these steps using the algebra and the shortcuts and so on. Okay, so that's one method of solving that question, okay? But there is an alternative method that maybe you would prefer to use. So remember, the question is this. Okay, we know what the answer is now. We've done it one method. So, you know, the other way that you could look at this is to regroup like terms on either side. So I'm recognizing that we're adding 2/3 on this side. If I take it over to the other side, we're going to reverse that sign. So we subtract. So we have 5 over 2, and then we're going to subtract 2/3. And then on the left-hand side, we still have our 6 over y. Okay, so remember, this is tricky because what we want to find, the value of y, is in the denominator of the fraction. So, you know, that's always a little bit trickier. So now we've put all our like terms on the right-hand side, the two fractions, okay? So now what we have to do is we have to do that subtraction of fractions. Okay, and the easiest way to explain that from my previous video, where we looked at subtracting, adding and subtracting fractions, which is always a little bit trickier, is to change these into fractions with the same denominator. So we've got to look for the lowest common denominator. So here, our denominator is 2 and this one is 3. So if we look at the multiples of 2, 2 times 1, 2 times 2, 2 times 3, and so on. If we then look at the multiples of 3, 3 times 1, 3 times 2, 3 times 3, and so on, we can see that they match at 6 here. So this is our common denominator, the lowest common denominator of 2 and 3. Here is 6. So we can now convert these fractions so they have the same denominator of 6. So how we do that, reminding ourselves that 2, if we multiply that by 3, that gives us the denominator of 6. We have to do exactly the same to the 5, the numerator, multiply it by 3. 5 times 3 is going to give us 15 over 6. Okay, so that we keep it balanced. and we've got the same value, equivalent fractions there. Likewise, we know that if we do 3 times 2, that will give us 6. We have to do the same to the numerator, 2 multiplied by 2, so that gives us 4 here. So now, on the left-hand side, we still have 6 over y. We don't want to forget that. But on the right-hand side, now we can subtract those fractions, common denominator of 6. So we can just subtract the numerators. 15 subtract 4 is going to give us 11 over the same denominator of 6 here. Now, what we have is we have something extra here, another technique that we can use in math, because we have a fraction on the left-hand side, 6 over y, is equal to another fraction on the right-hand side, 11 over 6. So whenever we just have a fraction equal a fraction, we can now use the technique of cross-multiplying to cross-multiply. And what that means is that, again, just kind of keep the equals in a straight line down the page here, is that we can do it either way, but we can look at y, so we can kind of multiply diagonally here. Okay, so we're looking at y multiplied by 11, which gives us 11y, and then that's equal to the opposite multiplication. 6 times 6 is 36. Okay, so we could have done it the other way around. We could have done 6 times 6 gives us 36 is equal to y times 11, 11y. Either works, okay, because then we're going to isolate y. So I'm just going to stick with the first one that I did, but either works to do that. So now we want to isolate y. We know that we're multiplying y by 11. So if we take it over to the other side, we're going to do the opposite of multiplying, dividing. So 36 divided by 11. And we're now going to isolate y. So we get our answer here. So on the left-hand side, we have the variable that we want to solve for, y, and then equals, and then the numerical value on the right-hand side. Now we actually have an improper fraction here again. So that is perfectly fine. I would kind of leave my answer like that, but we could change it to a mixed number if we wanted to, and we already know that that gives us this answer here. So we could do that too. Okay, but hopefully if we've done the arithmetic correct, we can see that we get the same answers here. Okay, but with the 2 different methods. So, again, choose the method that you feel most comfortable with. Sometimes you might not see one particular way of doing something. You see another method, go with that. Okay, sometimes we don't always do it the quickest way. We kind of do the method that seems, more comfortable for us. So just to give you an idea there of those types of questions, using algebra, isolating a particular variable to find that unique value. So that's kind of what we've covered here with an introduction to sort of algebra and solving an equation with one variable. Fractions come into it, hence you can see that fractions is a really critical skill to have, and we use it in all areas of math too. Okay, so basically to kind of sum up with what we've looked at in the algebra topic are some key takeaways. So things that we can just remember when we're using algebra for these types of questions. So the first kind of point to make is that algebra is actually it's its own language, okay? And we have certain terminology and notation that we use. So it is a mathematical language. Second thing is, make sure that you can distinguish between a mathematical expression and an equation. So that is really important when we're working in algebra. Okay, so distinguish. Okay, and the third point, solve equations with unknowns using the 4 shortcuts. So, you can see how useful they are if you can kind of see that connection. Okay, so we first explained how that works, but then we kind of see the shortcuts that we can use when we transfer it over the other side in an equation. So use those 4 shortcuts, you know, to do questions quicker when you have a mathematical equation. So when we're solving equations, use those 4 shortcuts. Okay, so remember we can use, when we're using X and Y, they're known as variables, they're known as unknowns. You know, we're isolating for those X's or Y's. So you just be familiar with that kind of terminology. And just 3 questions for you to try with their answers. So you might find these useful just to practice a little bit. Okay. And then the answer, you will get X is equal to positive 2 there. And this question, okay, so 3 and then bracket Y plus 7, close bracket, minus 3 is equal to 9. And then you should find that the value of Y comes out to negative 3. And then this last question, which is really tricky, okay, similar to sort of the last question we did, number 11. So see if you can do this, where it will come out to be X is equal to positive 2. So that was just kind of an introduction to some algebra with expressions, first of all, adding like terms when we're adding and subtracting, and then moving on to solving some simple equations with 1 variable. If you need extra help, please reach out to me using the links found in the description below. Also, check out our other videos that we're making. Thanks for watching.